Hello Math 2 students. Today we're going to use completing the square again. But the reason we need to use it today is we want to change an equation that's in standard form into an equation that is in vertex form. We've changed an equation in standard form into an equation in vertex form before without using completing the square. So quickly, if you watch this example, I'm going to run through really fast how you already know how to do the problem. Then we'll slow down and we'll write down how to do it completing the square. As you can see, when we took the equation y equals negative 3x squared minus 6x minus 9, which is in standard form, and we found a, b, and c, and then we used x equals negative b over 2a to find the axis of symmetry, and then we plugged that x value into our equation and found the y coordinate of the vertex was negative 6. We knew the vertex was negative 1 and negative 6, and our a value was negative 3, and we just plugged the vertex and the a value into vertex form. And we found out that in vertex form, our equation is y equals negative 3 times the quantity x plus 1 squared minus 6. If we take our original standard form equation and put it in a graphing calculator and take our vertex form equation and put it in a graphing calculator, both graphs will look exactly the same. So both of these equations represent the same graph when you put it on an x and y axis. Now, what we want to try to do today is figure out if maybe we can get the equation into vertex form more easily by using completing the square. Don't forget to get out your notes and write down this example. On all of our previous completing the square problems, there was no y value. There might be a number on the left and a number on the right and some x's, but now our equation is the form that it needs to be in if you're going to graph it. And so this changes a little bit what we need to do. The first thing I noticed though, if I want to complete the square, my a value is not 1. So I want my a value to be 1, I want my b value to be even, and so I need to fix that problem. So I'm going to divide every part of my equation, every term, by negative 3. Sometimes when you divide, it results in a numerical answer. Sometimes when you divide, it just results in a structure that represents division. That's going to happen in this problem. When we try to divide y by negative 3, it's just going to stay y over negative 3. But when we divide negative 3x squared by negative 3, we get positive 1x squared, which is what we're looking for. Negative 6x divided by negative 3 is positive 2x. And negative 9 divided by negative 3 is positive 3. So there's my problem. Now, I want to replace the c that's there with a c that will form a perfect square. So I need to replace that 3, which is not a perfect square, with a number that is a perfect square. So I need to move that 3 out of there. So I'm going to do that by subtracting 3 on both sides of the equation. So I'm going to subtract 3 on the right side of the equation. I'm also going to subtract 3 on the left side of the equation. And the resulting equation will look like this. Negative 3 plus y over negative 3 equals x squared plus 2x. So I'm replacing the c that was there, which is positive 3, with a c that'll form a perfect square. So my b value right now is 2. And as we know, we want to take our b value, which is 2, divide it by 2. That will give us 1. Then whatever number you get when you divide it by 2, you square that number. So 1 squared is 1. So the number that will form our perfect square trinomial is 1. But if I add 1 to the right side of the equation, I have to add 1 to the left side of the equation. So now over here in front of my negative 3, I'm going to add another 1. So far I subtracted 3 from both sides of the equation and I added 1 to both sides of the equation. I know the algebra is starting to look a little scary, but hang in there. Just write down every step and pay attention to the fact that we're not using any steps that you didn't learn the first few weeks of solving equations when you were in junior high. Now I'm ready. I have a perfect square trinomial, and I'm looking for two numbers that multiply to 1 but add up to 2. So that will give me x plus 1 and x plus 1. So those two binomials are the same, so I'm going to have x plus 1 squared. And on the left-hand side of the equation, I'm going to put the positive 1 and negative 3 together, which will give me negative 2 plus y over negative 3. Now I need to turn it into vertex form. So I'm going to add 2 to both sides. And I have y over negative 3 equals the quantity x plus 1 squared plus 2. Now I have one last step. Since I have that negative 3 underneath the y, I need to multiply every term by negative 3. So on the left-hand side, when I multiply by negative 3, the negative 3 on the bottom will be divided out by the negative 3 that I'm multiplying by. And I'll have negative 3 divided by negative 3 is y. And then the quantity x plus 1 squared, when I multiply that by negative 3, I will have negative 3 times x plus 1 squared. And finally, when I take the 2 and multiply it by negative 3, I will get negative 6. So as you can see, the vertex form of the equation that we got by using completing the square matches the vertex form of the equation that we got by using x equals negative b over 2a and plugging that x value back into our equation. I hope that this video helped you understand how you can change an equation that's in standard form into vertex form by completing the square.